Welcome to the next example, example 2.4. We are given a question where we have a delta star system, and we are given the impedances, and we are given the references. Reference is EAB, EAB. Okay, EAB is at angle 12. EAB is at angle 12 degrees. So if EAB is at angle 12 degree and it is negative phase sequence, EBC will be at angle 132 degrees, whereas we have EBECA also to be at angle ECA will be at angle minus 108 degrees. And these are the phase voltages, ECN at angle minus 78 degrees. And we're going to have our E, because it's a negative phase sequence, phase will always lead. So we are going to have our EAN at angle 42 degrees. Right. Then we're going to have our EBN at angle, that is plus 30 degree, 162 degrees. And that is what our phasor diagram would look like. The next thing you want to quickly, because we are asked to use the Millman's theorem to solve the problem. That is, use Millman's theorem and calculate the line currents. We want to calculate the line currents IA, IB, and IC. So the very first thing you have to calculate your BSN, which is as written up there. BSN is EANYAA plus EBNYB plus ECNYC over the sum of all the admittances. So you find your EAN. EAN will be what? EAN is this at angle 42 degrees. Don't forget that the voltage given to us is 380, which is a line voltage. I told you whether it is even given, shown, it is indicated or not, what it is, whether it is indicated as line or phase. If it is voltage given, if it is not indicated as phase, you take it as line. If it is not indicated at all, you take it as line. You assume it's line. If it is phase, they will indicate it as phase. But this time around, it is indicated as line. So you know it's a line voltage. And in the meantime, you need EAN. So EAN, if EAN is, if EAB is 380, then to convert it to the phase, it will be divided by root 3. So it will be 380 divided by root 3. 380 at what angle? EAN is at angle 42 degrees. Plus EBN also will be 380 divided by root 3 at angle 162 degrees. Then you have what? ECN, which is also 380 divided by root 3 at angle what? Minus 78 degrees. Minus 78 degrees. Then you divide it by Y, that is YA, which is the inverse of the impedance. That is 1 over the impedances given. Impedances given, these are the, let's put it this way to make it easier. Because we have only determined EAN and we need YA. Our YA will be times 1 over Z. So let's put it at this. Let's put this as our YA, which will be we know the impedance. It will be 17.5 at angle minus 34 degrees. That is 1 over YA which will be that's why A will be 1 over the impedance. Then also here, our YB will be 1 over ZB, which is 13.9 at angle 68 degrees. Then you have also our YC, which is 14.2 at angle minus 49 degrees. So that gives you the numerator. Then the denominator will be 1 over 17.5, that is YA at minus 34 degrees, plus YB, which is 1 over 13.9 at angle 68 degrees, plus 1 over, that is YC, 14.2 at angle minus 49 degrees. So when you solve for VSN, what do you get? You get 209.992 at angle 44.22 degrees volts. That gives you your VSN. Now that you have your VSN, let's not forget what you are trying to find. What you are trying to calculate is you are trying to calculate the line currents. And the line currents, which is IA, for example, this voltage here, because here is S now, because there's no neutral. So this is VAS. This point is S because there's no neutral. This is VAS. So IA is equal to IA is equal to IA is equal to VAS over ZA. We want to calculate IA. Our VAS, so that means we need to find what is our VAS, then we divide by ZA. And how do we get our VAS? Let's look at how we get our VAS. Our VAS is equal to what? VAN minus VSN. Right. So you have to determine, you go to the phasor diagram to look for your VAN. Our VAN on the phasor diagram is at angle 42, which is 380 at angle 42 degrees divided by root 3, because it's phase, minus VSN, that is the voltage that we get here, which is 209.992 at angle 44.22 degrees. So that will give you your VAS, right? So that once you get your VAS now, you can divide it by your ZA. Once you get your VAS that you are identified, that you get here, you can put it in and divide by your ZA. That will give you your IA. The same thing is applicable to getting your IB. To get your IB, this current, you have to know the voltage here, which is the voltage across here is VBS. So VBS divided by ZB will give you IB. So IB is equal to VBS divided by ZB. Right. So all you need to do is to determine what is VBS. VBS is equal to VBN minus VSN. So your VBN is at angle 162. That is 380 because it's phase voltage minus 162 degrees divided by root 3. That is VBN minus VSN, which is the VSN that you have here, which is minus 209.922 at angle 44.22 degrees. So that is giving your VBS. And once you get your VBS, you divide it by the impedance ZB, you get your IB. You do the same thing for IC. Your IC also will be VCS over ZC, where your VCS is BCN minus BSN. And what is your BCN? Your BCN is as given here, which is 380 divided by root 3 at angle minus 78 degrees. Then you subtract VSN from it, you get BCS. Then you divide it by the ZC, you get your IC. And those are the line currents that you are asked to calculate. Thank you.